All right, today we are diving into the science hiding in plain sight, inside something you see pretty much every day. We're talking about a simple piece of bread.
So, what happens when bread gets wet? I mean, it seems like such a basic question, right? But for food scientists, this is actually a huge deal. It's the key to making better food. Food that tastes better, lasts longer. And the answer? Well, it's way more complicated than you'd think.
So, to get to the bottom of this soggy bread mystery, scientists have a special procedure. It's called a swelling study. Basically, it's a super precise way to measure exactly how much water something can soak up, and that one measurement tells them a ton about its internal structure. Now, the go-to tool for this is a test that gives you a single number, the Water Absorption Index, or WAI. You can just think of it as a hydration score. The higher the WAI number, the more water the bread can hold. Simple as that.
Okay, so how do you actually measure this? Well, the first idea, the most obvious one, seems pretty simple. You take the soft, fluffy inside of the bread, that's the crumb, you grind it down into a fine powder, and then you just see how much water that powder can absorb. Makes sense, right?
And look at how precise this method is. It's a whole multi-step protocol designed so any lab can get the same results. You mill the crumb, you add water, and then you stick it in a centrifuge, one of those machines that spins really, really fast, to separate all the extra water. What you're left with is just the fully saturated bread sediment. It really seems like the perfect, scientific way to get a solid answer.
But, and this is where our little scientific detective story takes a turn, this seemingly perfect method has one giant fatal flaw. And here it is, the heart of the problem, that very first step, the grinding. It completely obliterates the one thing the scientists are trying to study in the first place, that delicate, airy, sponge-like structure of the bread. It's kind of like you're destroying the evidence before you even start the investigation. Imagine you want to know how a sponge holds water, but the first step of your test is to turn that sponge into dust. Yeah, you'll learn something about the material the sponge is made of, but you learn absolutely nothing about the structure that makes it a sponge.
So, if grinding the bread is a no-go, how in the world can our scientists see what's happening inside the crumb without, destroying it? Well, this is where they bring in the big guns.
To solve this, you can turn to some seriously powerful imaging tech. We're talking micro-CT scanners, which are basically medical CAT scans but for food that build a full 3D model of all the tiny air pockets. Or you could use laser microscopes to literally watch the swelling happen live. There are even special electron microscopes that can take pictures of wet samples without messing them up. Amazing stuff. But here's the catch. While all that high-tech gear is incredible, it is also incredibly expensive and complicated to use. It's not the kind of thing you find in every food lab. So that reality sent scientists on a hunt for a much smarter, more accessible solution. And that hunt, it led to a really ingenious breakthrough, one that's both scientifically brilliant and, believe it or not, remarkably low cost.
The big idea is actually pretty simple, but it's a total game changer. Instead of dunking a piece of bread into liquid water, which causes all sorts of messy side effects, the new method just lets an intact piece of bread absorb moisture straight from humid air, which, if you think about it, is a lot closer to how bread actually gets stale in your kitchen.
And the chemistry behind this is just so clever. All you need to create a perfectly humid little world is a sealed box and some salty water. And as you can see, different salts, even regular old table salt, will naturally create a very specific and stable level of humidity in the air above them. It's like having a thermostat for moisture. It's fantastic. The process itself is just beautiful in its simplicity. You just pop your little bread cubes into this mini greenhouse, you set them on a mesh so they're not actually touching the salt solution, and then you just weigh them every so often. That's it. As the bread soaks up water vapor from the air, it gets heavier. No destruction, no million-dollar machines, just a scale. Okay, but just writing down a list of weights over time is really only half the story. The final and really crucial step is to figure out what those numbers are actually telling us. We've got to decode the data. And to do that, scientists turn to the power of math. They use specific mathematical models that can take that simple list of weights and transform it into a really clear story about how fast the bread absorbs water and how much it can hold. And one of the most powerful tools they use for this is a formula called Peleg's model. It's built specifically to analyze that curve of weight gain over time and pull out the two most important pieces of information. It finds the hidden story in the numbers.
So what Peleg's model spits out are two key values. The first one, called K1, tells you the initial speed of absorption.
basically how thirsty the bread is right at the beginning. And the second one, K2, tells you the total capacity, how much water it can possibly hold when it's totally saturated.
And that's it. All that elegant science, all that careful measurement, it all comes down to just two numbers. But with those two little numbers, a food scientist has everything they need. They can compare different recipes and know with certainty which loaf of bread is going to stay fresh the longest.
Look, this whole scientific detective story, from the busted first attempt to this really clever low-tech solution, it has a very, very real impact on the food that you and I buy and eat every single day.
Understanding exactly how a breadcrumb soaks up and holds onto water is the key to making products that just feel better when you eat them, that stay fresh on the shelf for way longer, and, this is a big one, that ultimately help us fight the enormous problem of food waste. This is science you can literally taste.
It just goes to show you there's a whole world of fascinating science and brilliant problem solving hiding in the most ordinary things. It really makes you wonder, doesn't it? What other secret science is just sitting there on your kitchen counter right now?